Good evening, everyone, and thanks very much for coming out this evening. My name is Francis Mackin, and I'm just going to be talking to you a bit about the hydrology of bogs and raised bogs in particular, and talking about a bit of the work that we're doing in this area on Fortran Bog, where we're doing a bit of hydrological monitoring. So active raised bogs were once very common across Ireland. There was once 310,000 hectares of active raised bogs. As you can see in the image on the left, that's the pink shaded areas. But now we're down to less than 1,700 hectares of active raised bogs. So we've lost a very significant proportion. We're less than 1% of the original extent of active raised bog remaining. So it's a really unique and really rare habitat that only occurs in certain parts of the world, and Ireland has one of the last, I suppose, strongholds of active raised bog remaining. When we talk about active raised bog, I suppose what we have to understand is that we're talking about raised bog that's still accumulating peat. The peat is still forming, it's still sequestering carbon from the atmosphere, and it's in really good condition, which provides a wide range of benefits, not just in terms of biodiversity, the unique habitat itself, but all sorts of additional ecosystem services, such as purifying our water supplies, mitigating floods, and I suppose the key one that we're all aware of, I suppose lately, is sequestering carbon, taking carbon out of the atmosphere. So the image on the left is really high quality central ecotope, the best quality active raised bog. And if the slide will move, the image on the right then is marginal ecotope. So this is where the bog has been dried out. So it hasn't been cut away, but it's been drained, either by drains on the surface of the bog or at the margin where turf cutting has taken place. This dries out the bog, causes the peat to subside, increases the surface slope, and means that water flows more rapidly off the bog. So hydrology is really key to the different plant species that we get across these bogs. We need three key ingredients for a good quality raised bog. We need nutrient poor water supply, so that means adequate amounts and frequency of rainfall. We need very low infiltration rates down through the bog to depth. So this means that we need something that's quite impermeable at the base, or we need quite high groundwater levels. In the past, this was, I suppose, understood to always be the case, but we know now that a lot of bogs are groundwater dependent. They rely on very high groundwater levels. So when we have activities in the surrounding area, such as drainage or even extraction of material for quarrying that results in dewatering, this can impact on raised bogs. And the final thing that we need is very gentle topographic gradients. So the surface of the bog has to be very flat, and that's to limit the amount of overland flow that we get. So the way that we monitor bogs is we use piezometers, and these are basically tubes that are inserted into the bog surface, and then they allow the water to flow in, and then the water, as the water table moves, the water level within the piezometer moves up and down. So we have different ways of monitoring that. We can go out and we can manually measure the water table, or we can put in automated data loggers to record that at a more frequent basis. At Fortran Bog, we're currently monitoring the water table with manual monitoring. So we're going out there monthly, recording the water table, and just getting a picture of the condition of these bogs. I suppose the key things that we're seeing are that in some areas the water table has remained very close to the surface, where there's no evidence of any drainage or any damage. But as we approach the margins of the bog, where there's more drains, we see that the water table is slightly deeper. We're just starting to enter the summer period, so it'll be interesting over the next couple of months to see how the water table responds to higher temperatures, more evapotranspiration of the bog, and I suppose less rainfall in certain months. So this is just an indication of some of the results that you can get from your hydrological monitoring. The image on the left gives us a continuous record with hourly data. This is when we use data loggers. And what you can see is the water table was dropping down to about 50, 60 centimetres in this location during the summer months. We carried out restoration work, indicated by the yellow line, and then the water table came right up above the surface. So what we want is we want the water table to remain within 10 centimetres of the ground surface for 90% of the year. So that means it might only take a 2 to 3 week period in the summer for the water table to decline down to 50, 60 centimetres to mean that the really important species that grow across these bogs, the sphagnum mosses, the bog builders as we call them, can't survive in those sorts of conditions. Those drought conditions dry out the mosses and they simply can't survive. So with restoration and blocking of drains, what we want to do is stabilise that water table, bring it up closer to the surface. The image in the right here is actually from the same well, and it just indicates the data that we collect on a monthly basis with manual measurements. So what you can see is that we get a good indication of the range of water table fluctuations, but we do sometimes miss those very extreme drought periods. So this is why during summer months, it's worthwhile sort of increasing the frequency of the monitoring. And that's what we're going to do at Fortran Bogs. We're basically going to go out more frequently in the summer months and make sure that we capture those drought conditions. I was just then very briefly just going to discuss how we actually go about restoring some of the bogs. So we have best practice guidance for raised bog restoration. This is some guidance that we published back in 2017 and really sets out how we go about some of the very basic restoration measures such as peat dam construction, plastic dam construction and felling of conifer plantations. We're currently working on a 2024 revision, so we hope to have that published later this year, and that includes more details of more enhanced measures, things like cell bunding and I suppose contour bunding measures that are more intensive but potentially give us better results in more challenging areas. So this is the process of how we go around developing a restoration plan. We start with hydrological characterisation and baseline monitoring. We model the restoration potential of the bog, and very often that's very closely associated with the topography, so how steep the slopes are, where we have flow going through particular locations, and we can model that from desktop assessments. We then map all of the pressures. That includes things like drainage features, forestry, turf cutting, and then we go out into the field and we verify those pressures. We identify the depths of the drains, what the substrate material is underneath the drains, and we also suggest that ecological surveys are carried out to make sure that restoration doesn't impact on any areas that are particularly sensitive or any very important species that we come across. We refine the restoration plan and then develop a detailed specification and costings that then goes out to tender to contractors to carry out this work. So this just gives a typical example of what a restoration plan looks like. So what you can see with the different shading and the different colours is just an indication of all of the different drainage features and bundling measures that we propose across the site. This is Scohaboy Bog NHA in County Tipperary, and this is a site where we've probably implemented over 90% of the restoration measures required to return this site to favourable conservation condition. So this is a site where there's been a huge amount of restoration work carried out by Coillte, National Parks and Wildlife Service, as well as very significant involvement from the local community. So when we develop these restoration plans, this is some of the data that we would collect out in the field. So it would be information on drainage widths, drainage depths, whether the drain's actively flowing, whether we need to change anything within the restoration plan. And all of this information is just collected, taken back to the desktop, and we refine the plan. Peat dams are probably one of our key restoration measures and something that it would be ideal to see implemented at some of the bogs in this local area, where there are drains that are lower in the water table and meaning that the sphagnum mosses aren't as extensive as they can be. Peat dams are really effective when constructed properly. We don't need to import any materials. They really blend into the landscape well, and they're very cost effective. So once you get a machine on site, peat dams can be implemented very quickly. The most difficult aspect of peat dams is that where the bogs got a very high water table, it's difficult to get machinery into there. So in those cases, we usually opt for an alternative such as plastic dams. Peat dams are also much more susceptible to erosion. So if there's a lot of active flow in a drain, we would recommend an alternative such as plastic dams. So this is just an example of some of the restoration work that has been carried out across some of the bogs in the Midlands. And what you can see here in the image is just the little peat dams that are well keyed into the base and the sides of the drain, and they just sit above the level of the drain to allow for further subsidence of the peat over time. What you can see in this image is that in the flat area of the bog that we're looking at here, the dams are quite spaced out. So typically we're looking at 30-metre spacing and very flat topography. But what you can see as we go towards the margins of the bog and that slope starts to increase is we have the dams much more frequently. So typically what we want is we want a dam for every 10 centimetre fall in elevation, and that just keeps that water level within the 10 centimetre range of the surface. Just some more examples, and these dams were implemented by a specially adapted machine with plastic tracks, which just minimises the amount of damage caused to the bog. So you can see there the machine, how wide the tracks are. That brings the ground pressure of that machine down below 1 psi, which means that it actually has less of an impact than someone walking across the bog surface. The next measure that we're going to talk about are plastic dams. So plastic dams can be really useful, like I said, in areas that machinery can't get into, but also areas where there's a lot of active flow. They can be put in by hand, so work really well in areas where it's very difficult to get a machine for just a small number of dams. So these can be carried in. They're installed usually with a rubber mallet, just hammered into the base of drain, keyed out to the sides, and usually with a notch in the middle to prevent erosion around the edges. I suppose the advantages are that they're very effective in a wide range of conditions. They can be installed by hand. It's much lighter material than timber, so it's easier to carry into areas. And like I said, effective in drains with active flow. The downside is you're bringing in a non-natural material into the bog. There's potential issues with microplastics, and then they are more expensive than peat dams, usually about 3 times the price. And this is just a typical example of a plastic dam installed in a drain where it's not possible to get machinery in. So even though there's a drain that was infilling with sphagnum here, it's still a preferential flow path. And we want to block all those preferential flow paths to ensure that during summer, the water table is kept as close to the surface as possible. Another example here is where it's very difficult to get machinery in. So there's a lot of tree coverage. We would have to fell a lot of trees to block these drains, and it just made much more sense to bring plastic in. They're really effective in scenarios where we want to control the height of the water level. So this is a particular example next to an amenity track where we wanted to bring the water level up within the drain, but we didn't want to flood the amenity track. That means we can control exactly where the water level sits and make sure that it spills over and doesn't impact on the track. Another example is marginal bunding. This is a method that has really only been used in a small number of bogs in Ireland. One of them in County Cavan, Killyconny Bog, where a very long marginal bund was constructed along the cutover in 2008. It's really effective in that scenario because the cutover bog is very flat. The hydrological conditions in that scenario were controlled with weirs, so we had very good control of exactly where the water table sits. And then we saw a very significant expansion of the restoration potential, something like a 10-fold increase of what we would have expected compared to just drain blocking. So we published a paper on this that really just shows how this method can be really effective in increasing your restoration potential. But obviously the downside is it's a very expensive measure and really only works where your topography is very flat. So that's the example of Killyconny Bog. And you can see here the image on the left was 2008, shortly after construction. The image on the right was actually taken in 2015, just showing how rapidly the vegetation established at this site. What we've moved on to more recently is cell bunding. So this is sort of a mini marginal bund that we just talked about. And the advantage of cell bunding is that we're really controlling the water on a much smaller scale. So it can significantly enhance the restoration potential beyond standard drain blocking. It's typically only carried out on cutover areas. We control the water levels through the use of pipes or weirs through these bunds. And we've seen results from bogs such as Cloncrow in County Westmeath, where sphagnum and Eriophrum really colonised these areas within 2 to 3 years of construction. And I suppose the downside of this method is, again, it's expensive, and the steeper your slopes, the more expensive it gets because you need more bunds. This is a typical example of what we're looking for. It's almost like a paddy field type situation where we want to control the water level and just keep it within about 10 centimetres of the ground surface. We don't want deep water with this method. We want to maintain the water level maximum of about 10 centimetres above the ground surface in winter. In the summer, that means that the water table is usually within that 0 to 10 centimetre range below ground surface. This is the example of Cloncrow bog that I talked about. So you can see this is shortly after construction. Very rapidly we see the water levels increasing, and you can see here just the difference that 2 years has made. The image on the left is March 2021, the image on the right is June 2023. So within 2 years you can really see that bog cotton starting to colonise, and there's lots of sphagnum starting to come in. So bog cotton would be our very first coloniser, and that gives us the conditions that allow the sphagnum to come in. This is just some more examples of the conditions that we see. What you can see here is that we control the water levels in this scenario with the use of weirs. These are constructed from plastic dams, so very similar to the plastic dam scenario that I talked about, but it just lets us control exactly where we want the water level to sit. These are just some more examples of cutover bog. This is the All Saints bog in County Offaly, and you can see the difference that the marginal bunds have made. It's just really increased the restoration potential of these areas that previously really we would have only seen very small pockets of restoration to sphagnum, high sphagnum coverage. This method can be applied on burr peat areas. So this is another area of All Saints bog, and this is early on in the construction. You can see that the bunds very rapidly resulted in a rise in the water table levels, and then this is when the works were complete. So we've massively increased the restoration potential across this area over just drain blocking alone. Something that was quite nice with this project was the opportunity to, I suppose, put a bit of an artistic side of things into it. So there was some of the bunds were turned into a curlew, as you can see here. This is very, very early after construction. You can actually still see the machines working in this area. And I suppose what we want to see over time is that starting to fill up with sphagnum, and this will be visible from satellite imagery. This is the hydrological monitoring that we're carrying out at this site, and what you can see, again, the water table was dropping down to about 50-60 centimetres below the ground surface before restoration. Once restoration happened around October 2022, really we haven't seen that water table dropping below 20 centimetres. Bord na Móna are currently applying these methods on a much larger scale across 33,000 hectares of industrially cut sites across the Midlands. And what you can see here, some of the bunds that they have created as, I suppose, again, increasing the restoration potential over standard restoration measures. We've also started working more up in the upland areas, implementing similar measures, but we have to be more cautious in these areas. Typically, we're dealing with steeper slopes and more active flow. So in these scenarios, usually what we're dealing with are peat dams in the flatter areas, but moving into timber dams in areas where there's a lot of active flow. So just really to wrap up, we know that peatlands across Ireland have been subject to significant degradation. We talked about the significant loss of active raised bog that we've seen since, I suppose, over the past 400 years. But we're actually at a tipping point where we're starting to see more active raised bog come back due to restoration projects. So these bogs have significant restoration potential, and the bogs in this area are quite unique. There's not many bogs that are in the condition that the bogs around the Fortune bog area are in, and they have significant restoration potential. We've developed best practice methods, And the key is really about getting the water table up to the surface. This reduces our greenhouse gas emissions, results in expansion of the sphagnum mosses, and ultimately will lead to return of species such as curlew and species that previously would have used these bogs. And finally, really a multidisciplinary approach is key here. So I look at this from a hydrology and an engineering point of view, but it's really important to work with the ecologists and I suppose a whole range of experts to develop the restoration plans, characterise these sites appropriately and design and monitor the success of restoration plans. So thanks very much for listening, everyone, and happy to take any questions you might have.
Any questions?
No, it's interesting, the different damming system, and it's strange that the plastic dams are 3 times as expensive. I think the cheapest option would be to go in with a digger, a low ground pressure digger.
Yeah.
Brilliant that they can be down to 1 psi. It's, yeah, that's great. But you think that would be the cheapest option? How can plastic dams be 3 times as expensive?
They're 3 times more expensive than peat dams. So
yeah.
Peat dams are the cheapest option.
Yeah.
Yeah.
Yeah. It's a lot. Look, I can't imagine where it won't work. You know, as regards accessibility, maybe the forest or something else, and yeah.
Yeah, it's really only the only scenario once you can get a machine on the site. The only scenario where you wouldn't put a peat dam in once you actually have the machine there is a scenario where you've got very significant flow, and a peat dam would fail. So there's an example of a bog in County Galway, Aughrim bog, where Coillte carried out restoration work, I think around 2013, 2014. And they constructed very large peat dams and they put timber in either side of them to support them. In that scenario, because there's so much active flow and because there's the topography of the bog means that the water can't spill out of the drain, almost all of the bog drains through this one particular drain. Those peat dams failed in that scenario. What we done was we went back and retrofitted it with plastic dams. So it was only 7 dams. So you're talking about less than 1% of the dams that were implemented across the entire bog. But those dams are really robust and they've got a notch within them. So it means we've brought the water table up, but we've controlled it. So we keep it within the drain. We're not trying to, in that particular scenario, we're not trying to bring it right up to the surface. We're just trying to increase the water table as much as we can.
Yeah, I can see where there'd be flexibility with plastic.
Yeah. But it should be, like I said, it should only be a very small number. So an example of a restoration plan we developed was at Finderry in the Ox Mountains, and we put in 2,200 dams. I think 5 of them were plastic. So you only use it in a very select number of instances. You shouldn't be going out and putting plastic in everywhere. You should be using peat where you can and only reverting to plastic where it's peat basically isn't feasible. And very often that's just where there's so much flow that peat would wash away.
Yeah, when you say, I did observe the flow coming of the bog, the Falkland bog, I call it a Weena bog, where we were today. I was in at the other side with people who were looking at the land, and there was a massive flow. So maybe if you say a lot of the flow there would go the one way.
Yeah. But a lot of what we would try to do when we're developing a restoration plan is think about what's going to happen when we block the drain. So there might be a drain that's taking a lot of water, but if you're blocking the drain the whole way up slope, basically you might be spilling the water into a different direction. So by the time it gets down to the point where there's a lot of active flow now, a lot of that water might have spilled out, and you've dealt with it, and then peat dams are fine in that scenario.
Is there a minimum area? I mean, taking that it's feasible in the sense that it's flat and it's not, is there a minimum area that would be worked on for restoration?
There's no minimum area. So, like I said, if you wanted to go in and block one drain, that's going to make a difference for, a particular zone of influence depending on the characteristics of that drain and the surrounding peat. But one dam in the right location could make a big difference. We're out here basically on Fortune Bog to dip these monitoring wells. These are called piezometers or dip wells. What these are basically 1 metre long pipes that are perforated along the edges, and basically what that allows is us to measure the water table in this bog. So the water filters in through these slots and basically just moves up and down as the water table basically changes. So monitoring the water table manually with this is relatively simple. All we have to do is drop this into the well and just drop it down until we hear the sound of the end of it hitting the water. So there's kind of a bit of a knack to it once you sort of drop it down slowly until you hear the thud, take it back out, and then just double check exactly where that water level is at. So there we've got 40 centimetres. The other thing that we do here is that we measure the height of the pipe sticking up above the ground surface, and that allows us to calculate how far below the ground surface that the water table is sitting at. So here the pipe is at 28. So we just record those values and then just keep monitoring those over time to see how it varies. So at the minute we're currently in April and there's been a lot of rainfall over the past while, so I suppose we would expect the water table to be relatively high at this point in the year. But through the summer months, especially from now on, what starts to happen is that the plants themselves start to grow. We get transpiration from the plants and evaporation of open water. That's actually the main way that we lose water from bogs, is evapotranspiration. It's about 60% of the water that we lose. So what we'll see in the summertime is that the water table will drop further. Really what we want is the water table to remain about 10 centimetres, within 10 centimetres of the ground surface throughout 90% of the year. So it's very difficult to achieve that. When we look at a location like this, basically what we're seeing here is that the water table is a good bit below the ground surface, even though it's been very wet. So really in summer we'd probably expect the water table to drop to around 30 centimetres in a location like this. There's a number of drainage features you can see that are just running along here, and they would be lower in the water table. So ideally what we would like to do is come in, block those up with dams and raise that water table up and basically improve the condition of the vegetation that we've got here. Do you guys want to give it a go? Double check those measurements? All right. Yeah.
14?
Yeah.
So you're taking the 28 away from that?
Yeah, exactly.
So it's 120 below.
So it's 12 centimetres below the ground surface.
What was the other one?
The other one was 10 centimetres below the ground surface. So really it's not that surprising. Just
When you reach from this side, I'd say it's 27. So I don't know.
yeah, it's to do with how you measure the ground surface, and the
Yes.
ground surface is very difficult to measure in a bog because it varies so much.
Yeah, here you get 28. So
Yeah. And that's why it's useful to measure it every time, because then you get a good indication of exactly where it might be.
one here or try another one? Shall we go to another?
Will we try another one?
Yeah.
Yeah, I was just going to say across the way that ecologists map raised bogs in Ireland, they use the ecotope method, which is there are 5 main categories of ecotopes that are monitored. Central and subcentral are the best quality, and they indicate that it's actively peat forming, so it's sequestering carbon from the atmosphere. The peat's actively growing. In this area, I would say this is likely to be submarginal, which is the next one down. It indicates it's not peat forming, it's not sequestering carbon, but it's not emitting a lot of carbon either. In the last area that we were in, the heather was much taller. There was a lot more bare peat. I would say we were probably in marginal ecotope, and that's where you start to get more carbon emissions. So overall, like, not amazing quality here, but given that there's drains, it could really be improved, and you could get pockets of subcentral in this area.
You want to cover that?
Yeah. So we just put a cap on each of these wells, and it just stops rainfall going directly into the well. It's not usually much of a problem, other than if you're out here monitoring in very heavy rainfall. It just means that the water level can come up further in the pipe than the true water table is sitting at. Okay.